Alright, in this lesson we're going to look at these things called the rectangular coordinate system. So it is a way to look at two-dimensional space. We've seen previously where we had a number line going in one dimension, left and right. And we put the little marks on it with the positives and the negatives. And every real number has a spot on it. Okay? Well, now we're going to bump that up to the second dimension, where we're going to have two number lines crossed at 90-degree angles, so they're perpendicular to each other. This point in the middle is called the origin. And what we do is we take the positive, take the number line from the previous section, from our previous learning. We'll get my mouth going here in a minute. And we cross it perpendicularly with another number line. And we put the positive numbers going up and the negative numbers going down. And what this has going for it is it allows us to label every point in this plane with a unique address. Like this point would be 3, 5. The first number, it's always, our points are always looking like, we call them the x coordinates, comma, the y coordinate. Because this horizontal line we call the x-axis, and the vertical one we call the y-axis. And all your addresses over here, like this one 3, 5, or this one 5, 3. It's always the x-coordinate, comma, the y-coordinate, and the first number, which we call the x-coordinate, tells us how far and in which direction to move horizontally. We always start at the origin here, which has an address of 0, 0, because there's no movement in either direction. And so there's our reference point. Our anchor point for this system is 0, 0, that crossing point. We call it the origin. And so if we want to plot points, we have to tell the person how far to go and in which direction. Oh, sorry, stretching. How far to go and in which direction to move in both the horizontal and the vertical direction. The second number is the y-coordinate, and it tells us how far. I didn't put far up here. How far and in which direction to move vertically. So let's get another one over here that's clean. If I had graph paper, which I probably could go find some and import it in this program I just thought of. If I had graph paper, all these graphs would be looking awesome. I don't have graph paper, so I'm just going to write it, draw it out. Feel free to do the same. So like that 0.35, we're going to go over 3 units, positive 3 units, and up 5, because everybody's positive 3, 5. If we got it backwards, 5, 3, we would not end up in the same place. These are called ordered pairs because the order is important. If it had been 3, -5, then we'd still come over positive 3 in the x direction, but we'd go down 5 in the y direction. If it had been -3, +5. Here, -3, -5. And so on. I mean, we could plot any point. If we had points that we wanted to like graph this point on the x-axis, it's going to be 2, 0. This would be -4, 0. Anything that's on the x-axis here is going to have the same type of address. It's going to be some number, 0, because we want 0 movement vertically. Similarly, if we have points on the y-axis, they're all going to have a similar looking address of like 0, something. That point would be 0, 4. This point would be 0, -1. Everything on the y-axis looks like 0, some number. We're going to use that to our advantage, these two generic things, to go find x and y intercepts of graphs later on. But all that is someone living on the same street. I mean, Lubbock Christian's address is 5601 19th. Sonic's is 6501 19th. They both are on 19th Street, but the order of the numbers 5601 and 6501 make a difference of where you'll end up. So we have this coordinate system which allows us to plot points, allows us to graph equations and functions and all sorts of things, and some quick terminology. They talk about the 4 regions in the rectangular coordinate system as quadrants. Quadrant 1 is up here in the upper right-hand corner, and in quadrant 1, your x-coordinate and your y-coordinate are both positive. In quadrant 2, your x's have turned negative, but your y's are still positive. Down here in quadrant 3, x and y are both negative. And in quadrant 4, the x's have gone back to the positive side, but the y's are still negative. So we have those signs of the x and the y coordinates there. Just in some terminology. So I'll say something about, we've got something in quadrant 1, quadrant 2, 3, or 4. And so it just goes around counterclockwise in our numbering system. Excuse me. So, when we had one dimension, we had the absolute value could tell us the distance between 2 points, A and B. We could think of that as the absolute value of A minus B, and that would be the distance between those 2 points. Well, in 2 dimensions, we have a distance formula. Slightly more complicated, but we've gone up in a dimension, so that stands to reason. So now we have a point, let's call this point A, and we're going to label it x1, y1, and this point B, whose address is x2, y2. So we want to find the distance between these 2 points, this straight line distance. Well, from geometry, we can construct this vertical line here, if I can get my stylus to work, and we can construct this horizontal line here, and they're going to cross here and make a right triangle. So this point where they cross is going to have the same x-coordinate as point B, because it's the same horizontal distance from the origin, and it's going to have the same y-coordinate as point A. Okay, so we're given point A and point B, and from that we can construct this point. Let's call it C, but we're not going to really talk about it much here. So now notice we just have a right triangle, and so good old Pythagorean Theorem can come in and tell us certain things, like we want to find this distance between A and B. Let's call that D. So good old Pythagorean Theorem says that D squared should equal this horizontal side squared, the length of this horizontal side. Well, that's just a one-dimensional, that's a horizontal line, which absolute value will tell us that its distance is x2 minus x1. Pythagoras says we got to square it and add it to the length of the vertical side squared. So the length of this vertical side is just going to be the difference in the y coordinates. y2 minus y1 quantity squared. So we have d squared equals x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So then books will solve for d by taking the square root of both sides, and we get the formula for the distance between 2 points in the rectangular coordinate system is d for distance equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So we're taking the square root of that whole thing. For example, if we wanted to find the distance between the points negative 2, comma 3 and 4, 7, I'm just making up numbers, then we can find that distance. So we can find the distance between these 2 points by taking the square root of the x-coordinates, the difference in the x-coordinates. So it doesn't matter which number you pick first because you're squaring it. So, but I would get in the habit of picking this, making sure that you line up your x's and y's in the same order, because when it matters, then you don't have to think about it because you're already in that same habit. For example, down here I would do negative 2 minus 4 squared. That's the difference in my x-coordinates. Negative 2 minus 4. And then I would do 3 minus 7 squared for the difference in my y-coordinates. So then we just do the arithmetic. Negative 2 minus 4 is negative 6 quantity squared plus negative 4 quantity squared. So 36 plus 16. So that gives us the square root of 52 as the distance between these 2 points. I'm perfectly great with leaving it as the square root of 52. The book would not be. Bob, the back of the book, would write the square root of 52. It's 4 times 13, and then the square root of 4 is 2. So the back of the book would write it as 2 square roots of 13. I'm good with square root of 52. If I'm out in the real world, where square root of 52 is pretty worthless because there's not a square root of 52 on most tape measures, then I would just punch this into my calculator and get 7.211. So if those were 2 points on a map or between something in my backyard, because I have a rectangular coordinate system set up in my backyard because I'm a math nerd, then I would know that those 2 points were about 7.25 feet from each other, 7.25, give or take. Okay. Like I said, the order doesn't matter, so let me do it. If if you picked them in the other order. So if you had done d is the square root of 4 minus negative 2 quantity squared plus 7 minus 3 quantity squared. Then here 4 minus negative 2 is 6, square that. 7 minus 3 is 4, square that. So we get the square root of 36 plus 16, which once again is the square root of 52. So it doesn't matter which point you pick first. What I would, and in this formula it doesn't matter what order you subtract, but what I would encourage you to do is whichever x coordinate you pick first, you pick the y, you pick that point's y coordinate first, so that when it does matter, you don't have to worry about it because you're already in the habit of taking the x's and y's from the same point first. Okay, a couple other functional or another functional formula they give us is the midpoint formula. Sorry, I was interrupted. So we have the midpoint formula. That's what I get for doing these lectures in my office. People keep popping in needing me. So, but it's quiet and not at the house, so I don't have to worry about the dog barking. The midpoint formula, what it's going to do, it's going to find the middle point between 2 points. So it's officially stated as given any line segment with endpoints x1, y1, and x sub 2, y sub 2. The midpoint is simply the average of the x coordinates, comma, the average of the y coordinates. Which makes great sense if you're trying to find the point in the middle and you have two numbers. The point in the middle will be the average. So if we go get those 2 points, which I've probably forgotten, negative 2, 3, and 4, 7, the point that's halfway between each of those points is going to be negative 2 plus 4 divided by 2, comma, 3 plus 7 over 2. So you're going to get 2 over 2, comma, 10 over 2, which is the point 1, comma, 5. So halfway between negative 2, 3, and 4, 7 would be the point 1, 5. Okay? The other thing that they hand us in this section is the equation of a circle. And it's in this section because it follows directly from the definition, or the formula for the distance, or the definition of the distance. And you might need the midpoint formula also, so things are going together nicely here. But when you look at the definition of a circle is the set of all points x comma y that are a fixed distance from a fixed point. So you probably are familiar with terms for these. The fixed distance is called the radius. The radius of the circle. And the fixed point, which you're measuring everything from, is called the center of the circle. We typically use R for radius, and we typically use the letters H, comma, K for the center of the circle. I don't know why we use HK. I should go research that. Okay, went and did a little bit of research, and H and K are rarely used letters in math. Terrible reason to use them, but that's fine. So if we look at this definition, we can figure out what the equation of a circle is. What we know is that you're trying to find the distance between x comma y and h comma k is r. So if you look at your distance formula, which is d equals the square root of x of 2 minus x of 1 quantity squared plus y2 minus y1 quantity squared. If we plug in our players, the distance in the circle is called r. The difference in my x-coordinates is going to be x minus h quantity squared plus y minus k quantity squared. And I've seen some books leave the equation of a circle written in this ugly square root as r equals the square root of x minus h quantity squared plus y minus k quantity squared. Most of the time you'll see a book square both sides and write the equation as x minus h quantity squared plus y minus k quantity squared equals r squared. So that would be the equation of our circle. For example, if we had something that looked like x minus 3 squared plus y plus 4 squared equals 64, then this would be the equation of a circle with radius equal to 8. Because the right-hand side here is r squared, so you just take the square root of that to get your radius, which is 8. And the center is 3 comma negative 4. Up here, the y plus 4. We can think of it as y minus a negative 4 quantity squared. We always have to think of it, in the formula, it's y minus k. So down here in my problem, I purposely had y plus 4 to make this point. That a bunch of formulas in math and a bunch of math procedures want it as x minus some number or y minus some number. So that way, if we start thinking of it in that x minus some number format, your life is going to be a lot easier here in a couple sections down the road. We could graph this if we wanted to. It's going to be 3, 4. We're not going to 3, negative 4. We're not going to get really legalistic with the graph. I've run out of space on my iPad. And then the radius would be 8. So go around 8 in all directions there. That is it for this section. So basically, can you plot points in the x and y axis, the distance formula, and the equation of a circle. Oh, I just did that 5 seconds ago. And the midpoint formula, which is the average of the x-coordinates, comma, the average of the y-coordinates. That's it for this section. As always, you know how to contact me if you have any questions or problems. I will talk to you later. Bye.